Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. And in this session, we will be discussing about Floyd Warshall algorithm, introduction and example on Floyd Warshall algorithm also. What is this Floyd Warshall algorithm? This algorithm is for finding the shortest path between all the pairs of vertices in a weighted graph. In previous case, we are going to take a particular source. From there, we are going to find the path, this shortest path between the vertices. But here, it will be finding the shortest path between all the pairs of vertices in a weighted graph. Okay, this algorithm works for both directed and undirected graphs, as like Dijkstra's algorithm. But it does not work for the graphs with negative cycles. If you have negative cycles, then this algorithm won't work properly. And Floyd Warshall algorithm is also called Floyd's algorithm or Roy-Floyd algorithm or Floyd Warshall algorithm, or in short, we can represent it as WFI algorithm also. Okay. This is the introduction about the Floyd Warshall algorithm. Now consider the example and how we can able to find the shortest path for all the vertices. Okay. Consider here we are going to consider the directed graph G equal to V comma E and find the shortest path between all the vertices of the graphs using Floyd Warshall algorithm. And this is the graph given. Now, based on this graph, what is the first step we need to do is, here you should not have any loops, self loops you should not have, and any parallel edges you should not present, right? Based on that, construct a D naught. What is D naught representing? Observe. What are the vertices you have? 1, 2, 3 and 4. That will be represented in row as well as in the column. Okay. Now, write what are all the weights that was given, and for the remaining things what we need to place. What are the weights that was given for each and every edge represented? For 1, what are the edges you have? 1 to 2 and 1 to 4. 1 to 2 you have weight 8 and 1 to 4 you have weight 1. And the remaining places for 1 to 1 you don't have any self loop, so we are going to place with 0. 1 to 3 you don't have any edge connection, so we need to replace with infinity. Okay. Like this way, we need to fill the remaining values also. For 2 to 1, you don't have any edge, so place with infinity. For 2 to 2, you don't have any self loop, place with 0. And for 2 to 3, you have one edge with the cos or weight with 1, so we are going to place 1. And for 2 to 4, you don't have any edge, so we are going to place with infinity. Then, coming to 3 to 1, we don't have direct edge. 3 to 4 is 3 to 1 we have 4, right, with this one. 3 to 1 you have 4. 3 to 2 you don't have, so infinity. 3 to 3 you don't have any self loops, place with 0. And 3 to 4 you don't have any edge, so we are going to place with infinity. Next, 4 to 1 we don't have, infinity. 4 to 2, yes, we have, so we are going to place with 2. And 4 to 3, you have edge, so 9. And 4 to 4, you don't have any self loops, so we need to place with 0. This is a basic adjacency matrix we have represented from this graph. Now, by taking this graph, we are going to construct the remaining vertices, or we are going to find the shortest paths. From D naught, we are going to construct a D1, right? This is my D naught value. Now, to construct a D1, we are going to consider the first row and first column we need to leave. First row and first column we need to consider and we are not going to evaluate those row and column values. The remaining things we need to find out the values, right? Okay. Now, how to find these values? From D0, we need to get the values for D1. Okay. Now, I am going to find, after representing this, now observe what is the graph you are going to get it here. This is the graph, right? For D1, we have 1, 2, 3 and 4. 1, 2, 3, 4. Now, you have 0, 8, infinity and 1. And here you have 0, infinity, 4 and infinity. And we are leaving this row as well as column. And we don't bother about the adjacent, diagonal 0 values. We are going to place as it is. The remaining values we need to find. What are the remaining values we need to find? 2, 3 we need to find. 2 to 4 we need to find. And 3, 2 we need to find. And 3, 4. And 4, 2 and 4, 3. These are the 1, 2, 3, 4, 5, 6 values we need to find it from here. Now, how to find this? You have a formula for this to find the values, where I am going to consider the first row and first column we are leaving, right? From that, how we are going to find the remaining values? Now, you see, D0 of 2, 3. I need to find this value. D0 of 2, 3 I need to find. When I want to find D0 of 2, 3, D0 of, how to write this one? D0 of 2, 3 can be written as D0 of 2, 1. Why? Because I am taking 1 as the vertex in between 2 and 3. Why? Because we are not using that particular one vertex row and column also, right? And D0 of 1 and 3. Like this way we need to write. This 1 which we are not using, that will be considered as the middle vertex, right? Based on that, we need to find the remaining values. If I am going to consider second row and second column, in that particular case, we need to make that vertex as the mediator vertex in between those D0 or D1, anything if you are going to find it out, right? Now, based on this, now you find the value for this D0 of 2, 3. What is the D0 of 2, 3 value? D0 of 2, 3 value is 1. Yes, 1 I have placed. Then D0 of 2, 1 value. D0 of 2, 1 value is infinity plus D0 of 1, 3 value. 1, 3 value is how much? Infinity. So, 1 is less than infinity. If I am going to add infinity plus infinity, it is more value only. It is not lesser. So, 1 less than infinity is nothing but 1. That is a minimum value you are going to get, right? 1 is going to be placed in this position. Here we are going to get 1 value. Okay. Next, what is the next value I need to find? D0 of this position. D0 of 2, 4. I need to take which is the median vertex for 2 and 4. I am going to take 1, right? So, D0 of 2, 4. D0 of 2, 1 plus D0 of 1, 4 we need to take. What is D0 of 2, 4 value? 2, 4 value is infinity, right? And D0 of 2, 1 value, what is 2, 1 value is also infinity plus D0 of 1, 4 value, what is 1, 4 value is 1. Infinity plus 1 or infinity is almost greater than that. So, we are going to get the value as infinity only. Here I am going to get the infinity value. Okay. Next, I am going to find 3, 2. From this, we need to write D0 of 3, 2. We need to use the middle vertex as 1. So, D0 of 3, 1 and D0 of 1, 2 we need to write. Okay. Now, what is D0 of 3, 2 value? 3, 2 value is infinity. Is D0 of 3, 1 value? What is D0 of 3, 1 value is nothing but 4. Is 4 plus. And D0 of 1, 2 value. 1, 2 value is nothing but 8. 8 plus 4 is nothing but 12. Infinity is greater than 12. So, I am going to take the minimum value, that is 12. We need to replace here with 12. Okay. Next, D naught of 3, 4 we need to find. That means this part where I need to find. D naught of 3, 4 value is nothing but D naught of 3, 1. Why? Because 1 will be the middle value for 3 and 4. So 3, 1 and a D naught of 1, 4 we need to consider. Okay, middle vertex I need to consider, right? Now D naught of 3, 4, what is the value? 3, 4 is infinity. And D naught of 3, 1 is how much? 3, 1 is 4 plus D naught of 1, 4 is 1. So it is 5. Infinity is greater than 5. So I am going to consider 5 is my minimum value. So I am going to replace here with 5. Next, you have 4, 2. These two values also we need to find. When I am going to find 4, 2, D naught of 4, 1 plus D naught of 1, 2 we need to take. D naught of 4, 2 value is how much? 2. And D naught of 4, 1 value is infinity plus D naught of 1, 2 value is 8. Infinity plus 8 is nothing but the infinity value only. But 2 value is less than infinity. So we are going to take the value of this one is 2. That is the minimum value we are going to consider. Next, D naught of 4, 3. Where how you are going to write 4, 1 and 1, 3. And D naught of 4, 3 value is how much? 9 less than this much. D naught of 4, 1 is infinity and D naught of 1, 3 is also infinity. This is more value. That is 9 is less than infinity. So I am going to place here with 9. These are the values where I am going to get it after finding my D1. Okay. This is how where I am leaving the first row vertex and first column vertex. We are going to leave and we are going to find the remaining values from this. In the same way, we need to find it for D2, D3 and D4 also. Right? Let us see the next procedure, how we are going to find it for D2. And what is the graph we are going to get? Let us write the graph properly here. You have 1, 2, 3 and 4. 1, 2, 3 and 4. What are the values you have? 0, 8, infinity and 1. Infinity, 0, 1, infinity. 4, 12, 0, 5. Infinity, 2, 9, 0. Right? This is the final graph after finding D1. Now I need to find a D2. How to find a D2? Now which will be the middle vertex we need to consider. We need to consider second row column and second row or second vertex column and second vertex row we are going to eliminate and we are going to find the remaining values. Now based on this, what are the values you are going to get? 1, 2, 3 and 4. Here also 1, 2, 3 and 4. Okay. Now we need to place the second row column and second vertex column and row as it is and the remaining values we need to find. For second row or column, what is the values? 8, 0, 12 and 2. And for column or row we have infinity, 0, 1 and infinity. Okay. We need to leave these two row and column of second vertex and based on that now we need to find the remaining values and the diagonal values won't change, it will be always 0. Now what are the values we need to find here? D of 1, 3, D of 1, 4, D2 of 3, 1 and D2 of 3, 4 and D2 of 4, 1 and D2 of 4, 3. These are the values we need to find it out. Now first check for D of 1, 3. But here the vertex which we need to consider as the middle one is 2. Right? D1 of 1, 2. Right? D1 of 1, 3. For finding D2, we need to have D1 of 1, 3 and D1 of 1, 3 we need to do. D1 of 1, 3 is nothing but D1 of 1, 2 plus D1 of 2, 3. These are the two values we need to take. Why? Because 2 is the middle vertex. Okay. D1 of 1, 3. What is the value of D1 of 1, 3? 1, 3 is infinity. D1 of 1, 2 is 8 plus D1 of 2, 3. 2, 3 is nothing but 1. That is 9. Infinity is greater than 9. So I am going to take the minimum value and I am going to place 9 here. Right. Next, D1 of 1, 4 we need to find. D1 of 1, 4. What is the D1 of 1, 4 value? D1 of 1, 4 is nothing but we need to take 2 as a middle one. So 1, 2 and 2, 4. Okay. What is the 1, 4 value? 1, 4 value is 1 is less than. D1 of 1, 2 value. 1, 2 value is 8 plus 2, 4 value is nothing but infinity. So we are going to get 8 plus infinity is more value. 1 is less than infinity. So I am going to get the value as 1. Okay. The next one, D1 of 3, 1. 3, 1 is nothing but how we can write D1 of 3, 2 and D1 of 2, 1 we need to write. Now, D1 of 3, 1. What is the value for D1 of 3, 1? 3, 1 is 4 is less than. D1 of 3, 2. 3, 2 is 12 plus D1 of 2, 1. D1 of 2, 1. 2, 1 is infinity. So, we are going to get 4 is less than this one infinity. So, I am going to replace with 4. Right. Next, D1 of 3, 4. 3, 4 how we can write? 3, 2 and 2, 4. Okay. 3, 4 value how much? 3, 4 value is 5 less than. 3, 2 value is 12 only. 2, 4 value is infinity. So, it will be the more value. So, we are going to take the minimum value as 5. So, I am going to get 5 here. Next, in the same way, 4, 1. How we can write 4, 1? 4, 2 and 2, 1. Both the things. And what is the value of 4, 1? 4, 1 is infinity. And 4, 2 value is 2 plus 2, 1 value is also infinity. Okay. Now, you are going to get more or less infinity value only. And the last one, 4, 3. What is the 4, 3 value? 4, 3 value is 9. And 4, 2 value is 2 plus D1 of 2, 3 value is nothing but 1. So, we are going to get 3 value. 9 is greater than 3. So, I am going to take the minimum value. This is 3. Right. Like this way, we are going to find the D2 value. After finding the D2 value, now we need to find the D3 value. Okay. Now, for this, what we need to do? We need to select the third row and third column vertices. And based on that, we need to find the remaining values. Okay. Now, from this, what is the adjacency matrix? We are going to get 1, 2, 3 and 4. 0, 8, 9, 1. This is infinity, 0, 1, infinity. 4, 12, 0, 5. Infinity, 2, 3, 0. This is the final graph where we have got. Now, how to find the D3? 1, 2, 3 and 4. 1, 2, 3 and 4. Now, we need to consider the third vertex as it is. Row and column 0, 3, 4, 12, 0 and 5. This is the third row and column we have selected. Now, represent the diagonal elements as it is, zeros. Now, we need to find these locations. These values we need to find. What are the values? We need to find 1, 2, 1, 4 and 2, 1, 2, 4 and here 4, 1 and 4, 2. Right? 1, 2, 1, 4, 2, 1, 2, 4, 4, 1, 4, 2. These are the values we need to find. As we need to take the values from D2, right? D2 of 1, 2, how we can represent? D2 of 1, 3 and 3, 2. Now, here the middle element we need to consider is the third vertex. So, we need to represent 1, 3 and 3, 2. And what is the 1, 2 value? 1, 2 value is nothing but 8. 8 less than 1, 3 value is 9 plus 3, 2 value is 12. Right? 9 plus 12 is more than 8. So, we need to consider the minimum value. That is nothing but the 8. Next, 1, 4. 1, 4 value is 1. And 1, 3 value is 9 plus 3, 4 value is 5. 9 plus 5 is nothing but 14. but 1 is lesser than that, so I am going to replace this one with 1, right? Next, D2 of 2, 1, how we can write 2, 3 and 3, 1. This has to be written. And D2 of 2, 1 is nothing but infinity. 2, 3 value is 1 and 3, 1 value is 4. This is nothing but 5. 5 is the minimum value, so we need to place 5 here. Okay. Now D2 of 2, 4. 2, 4 value is infinity and 2, 3 value is 1 plus 3, 4 value is 5, right? 1 plus 5 is nothing but 6. Infinity is greater than 6, so we are going to consider the minimum value is 6. And the next one, D2 of 4, 1. 4, 1 can be written as 4, 3 and 3, 1. And 4, 1 value is infinity and 4, 3 value is 3 plus 3, 1 value is nothing but 3, 1, 1 is 4. 3 plus 4 is nothing but 7. We have the minimum value 7, so we need to place 7 here. And 4, 2. 4, 2, how much? 4, 2 can be written as 4, 3 and 3, 2. 4, 2 value is 2 and 4, 3 value is 3 plus 3, 2 value is how much? 3, 2 value is 12, right? But 2 is less than 15, so we need to take the minimum value, that is 2 we are going to get here, right? Like this way we are going to find the D3 value, right? After finding the D3 value, here we are going to get 2. Now we need to find the last one, that is D4. First we are going to consider the D3 which you got. What are the values we got it from D3? Represent 0, 8, 9, 1, 5, 0, 1, 6, 4, 12, 0, 5, 7, 2, 3, 0. Now we need to find the D4. For that, which of the vertex we need to take? Fourth vertex, row and column we need to consider. 1, 2, 3 and 4. What is the fourth row, column and vertex? 1, 6, 5, 0 and 7, 2, 3, 0, right? This row and this column we need to consider as a middle part of it, right? And the diagonal elements will be always 0, and we need to find this vertices values. Okay. Now what are the values we need to find? 1, 2 we need to find. D3 of 1, 2, D3 of 1, 3 and D3 of 2, 1, right? And D3 of 2, 3 and D3 of 3, 1 and D3 of 3, 2. These values we need to find it out. And in middle we need to take the vertex 4, right? D1 of 1, 2, how we can write? D1 of 1, 4 and 4, 2, right? Now what is 1, 2 value? 1, 2 value is 8. D3 of 1, 4 value is 9, 1, 4. 1, 4 is D3 of 1, 4. 1, 4 is 1, sorry. And D3 of 4, 2 is 2. Yes. But 8 is greater than 3, so I am going to take the minimum value. So we are going to get the value as 3. Next, D3 of 1, 3. We can write 1, 4 and 4, 3. Why? Because 4 is the vertex which we need to take as a middle part of it. So 1, 4 and 4, 3 can be written. And what is 1, 3 value? 1, 3 value is 9 and 1, 4 value is 1. And 4, 3 value is 3. So we are going to get the minimum value is 4. 4 we are going to get 4 is the minimum value. Next we are going to have 2, 1. 2, 1 can be written as 2, 4 and 4, 3. And 4 is the vertex which you need to consider as the middle. So what is the 2, 1 value? 2, 1 value is 5 less than 2, 4 value is 6 and 4, 1 value is 7. So we are going to get 13. But 5 is less than 13, so we need to place 5 here. Next, we need to find a 2, 3 value. 2, 3 value, how we can write? 2, 4 and 4, 3. What is a 2, 3 value? 2, 3 value is 1 and 2, 4 value is 6 and 4, 3 value is 3. So 6 plus 3 is 9, but 1 is less than 9, so we need to place 1 here. Two, 3 value. Here, sorry. 2, 3 values, this one, 1. This is not. Like this way, we are going to get the values, and we need to find leftover 2 more values, 3, 1 and 3, 2. 3, 1 can be written as 3, 4 and 4, 1. What is the 3, 1 value is 4, and 3, 4 value is 5, and 4, 1 value is nothing but 7. 12 is greater than 4, so we are going to take the minimum value as 4. And the last one, 3, 2. 3, 2 we have can be written as 3, 4 and 4, 2. And here 3, 2 value is nothing but 12, and 3, 4 value is 5, and 4, 2 value is 2. That is 7 is less than 12, so we are going to place 7 here, right? Like this way, we are going to represent the Floyd Warshall algorithm, right? We are going to find all 4 different vertices values, and we are going to find the shortest path between all the paths, right? And the summary, if you are going to see the Floyd Warshall algorithm, we have seen the introduction part of this Floyd Warshall algorithm and the example also, right? I hope you could understand this example also with the mathematical representations. Thank you.